Infrastructure components. Today's IT infrastructure is compared to 5 major components: computer hardware, computer software, data management technology, networking and telecommunications technology, and technology services. These components must be coordinated with each other. Computer hardware. Computer hardware consists of technology for computer processing, data storage, input, and output. This component includes large mainframes, servers, desktops and laptop computers, and mobile devices for accessing corporate data and the internet. It also includes equipment for gathering and inputting data, physical media for storing the data, and devices for delivering the processed information as output. Computer software. Computer software includes both system software and application software. System software manages the resources and activities of the computer. Application software applies the computer to a specific task for an end user, such as processing an order or generating a mailing list. Today, most systems and application software is no longer custom programmed, but rather is purchased from outside vendors. We describe these types of software in detail in section 4.2. Data management technology. In addition to physical media for storing the firm's data, businesses need specialized software to organize the data and make them available to business users. Data management software organizes, manages, and processes business data concerned with inventory, customers, and vendors. Chapter 5 describes data management software in detail. Networking and telecommunications technology. Networking and telecommunications technology provides data, voice, and video connectivity to employees, customers, and suppliers. It includes technology for running a company's internal networks, services from telecommunications, telephone services companies, and technology for running websites and linking to other computer systems through the Internet. Chapter 6 provides an in-depth description of these technologies. Technology services. Businesses need people to run and manage the infrastructure components we have just described and to train employees in how to use these technologies for their work. Chapter 2 describes the role of the Information Systems Department, which is the firm's internal business unit set up for this purpose. Today, many businesses supplement their in-house information system staff with external technology consultants. Even large firms do not have the staff, the skills, the budget, or the necessary experience to implement and run the wide array of required technologies. When businesses need to make major system changes or implement an entirely new IT infrastructure, they typically turn to external consultants to help them with system integration. Systems integration means ensuring that the new infrastructure works with the firm's older so-called legacy systems and that the new elements of the infrastructure work with one another. Legacy systems are generally older transaction processing systems created for older computers that continue to be used to avoid the high cost of replacing or redesigning them. There are thousands of technology vendors supplying IT infrastructure components and services and an equally large number of ways of putting them together. This chapter is about the hardware and software components of infrastructure you will need to run a business. Chapter 5 describes the data management component, and Chapter 6 is devoted to the networking and telecommunications technology component. Chapter 7 deals with the hardware and software for ensuring that information systems are reliable and secure, and Chapter 8 discusses software for enterprise applications. Types of computers. Business firms face many different challenges and problems that can be solved by computers and information systems. In order to be efficient, firms need to match the right computer hardware to the nature of the business challenges, neither overspending nor underspending for the technology. Computers come in any array of sizes, with differing capabilities for processing information, from the smallest handheld devices to the largest mainframes and supercomputers. If you're working alone or with a few other people in a small business, you'll probably be using a desktop or laptop personal computer, PC. You might carry around a mobile device with substantial computing capability, such as a BlackBerry, iPhone, or iPad. If you're doing advanced design or engineering work requiring powerful graphics or computer computational capabilities, you might use a workstation which fits on a desktop, but has more powerful mathematical and graphics processing capabilities than a PC. If your business has a number of computers networked together or maintain a website, you will need a server. Server computers are specifically optimized to support a computer network, enabling users to share files, software, peripheral devices such as printers, or other network resources. Servers have become important components of firms' IT infrastructures because they provide the hardware platform for electronic commerce. By adding special software, they can be customized to deliver web pages, process purchase and sale transactions, or exchange data with systems inside the company. You will sometimes find many servers linked together to provide all the processing needs for large companies. If your company has to process millions of financial transactions or customer records, you will need multiple servers or a single large mainframe to solve these challenges. Mainframe computers first appeared in the mid-1960s and are still used by large banks, insurance companies, stock brokerages, airline reservation systems, and government agencies to keep track of hundreds of thousands or even millions of records and transactions. A mainframe is a large capacity, high performance computer that can process large amounts of data very rapidly. Airlines, for instance, use mainframes to process upwards of 3,000 reservation transactions per second. IBM, the leading mainframe vendor, has repurposed its mainframe systems so they can be used as giant servers for large-scale enterprise networks and corporate websites. A single IBM mainframe can run enough instances of Linux and Windows Server softwares to replace thousands of smaller Windows-based servers. A supercomputer is a specially designed and more sophisticated computer that is used for tasks requiring extremely rapid and complex calculations with thousands of variables, millions of measurements, and thousands of equations. Supercomputers traditionally have been used in engineering analysis of structures, scientific exploration and simulations, and military work such as classified weapons research and weather forecasting. A few private business firms use supercomputers. For instance, Volvo and most other automobile manufacturers use supercomputers to simulate vehicle crash tests. If you are a long-term weather forecaster such as the National Oceanic and Atmospheric Administration, NOAA, or the National Hurricane Center, and your challenge is to predict the movement of weather systems based on hundreds of thousands of measurements and thousands of equations, you would want access to the supercomputer, or a distributed network of computers called a grid. Grid computing involves connecting geographically remote computers into a single network to create a virtual supercomputer. By combining the computational power of all computers on the grid, grid computing takes advantage of the fact that most computers in the United States use their central processing units on average only 25% of the time, leaving 75% of their capacity available for other tasks. By using the combined power of thousands of PCs and other computers networked together, the grid is able to solve complicated problems at supercomputer speeds at far lower cost. The business case for using grid computing involves cost savings, speed of computation, and agility, as noted in chapter opening case. The chapter opening case shows that by running its applications on clustered servers on a grid, BART eliminated unused computer resources, used existing resources more efficiently, and reduced cost and power consumption.